Hello, fourth graders. Today we will be working on this lesson 8 problem set. And once again, it focuses on fractions and specifically breaking up fractions. So breaking up parts of a whole. So today's focus will be on number bonds and representing fractions using number bonds. And number bonds are just, as I said, a way to represent a whole and then parts of a whole. So if we did this for a whole number, let's say 10, and we want to put 10 in a number bond, we might do 8 and 2, because 8 plus 2 is equal to 10. We might do 5 and 5, because 5 plus 5 is equal to 10. We might do 7 and 3, because 7 plus 3 is also equal to 10. Okay, you guys remember that? You get the picture with number bonds? So let's look at our sample problem. So it asked, show a number bond representing what is shaded versus what is unshaded in each figure. And then you also have an option to draw a different visual model that would represent the same number bond. So for the sample that they already did, the first thing they did was count the number of boxes in here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 total boxes. So we know that 8 will be our denominator. Okay. 8 is our denominator because 8 is the total. How many boxes are shaded? 1, 2, 3, 4, 5. 5 boxes are shaded. And then how many boxes are not shaded? 1, 2, 3. So 5/8 represents shaded, and 3/8 represents not shaded. And they represented this in the number bond with 5/8 over here and 3/8 or 3/8 over here. But this is just one figure, right? So on top of every one of these number bonds that you're going to represent, you're going to put a 1 on top because this is just one figure, right? You could also put 8/8 for our sample problem, or 8/8, because that means we're including all 8 of these into our number bond, into our problem. Okay? But at the end of the day, this is just one figure. This is just one figure. This is just one. This is just one. This is just one. Okay? So let's do one more sample problem, and then you guys will do 2, 3, and 4 on your own. Okay, so first things first, let's count the number of triangles in this figure. 1, 2, 3, 4, 5. So we know that our denominator, our number on the bottom, will be 5. Okay? Because that's the total number of triangles in this figure. How many of those triangles are shaded? 1, 2, 3. 3 are shaded. And to represent not shaded, 5. There's still 5 triangles in this figure. How many are not shaded? 1, 2. So in this number bond, we would put 3/5 to represent the shaded, and then 2/5 to represent the unshaded or not shaded. Because this shaded plus unshaded comes together to make just one figure. Okay, because we're just dealing with one figure. And if we wanted to, let's say, rewrite this in another figure, we could totally do that. So I have, let's do this, 1, 2, 3, 4, 5 boxes. I'm just drawing a different visual model. And 3 are shaded. 1, 2, 3. So this other visual model represents the same thing as this visual model. Okay. It isn't optional to draw another visual model. So you have a choice whether or not to do that for 2, 3, and 4, but definitely write the number bonds. Okay. And then on the next page, pretty much same situation. Question 5 asks, draw a number bond with 2 parts showing the shaded and unshaded of each figure. And then it's asking us to decompose both parts of the number bond into unit fractions. And if we remember from yesterday, we know that unit fractions are represent just one part of the entire figure. Okay, so for unit fractions, the numerator, or the number on top, should always be 1. So let's do the first one together. A. So if we're first drawing a number bond, we know that 1 goes on top because we're just representing one figure. Now, how many triangles do I have in this figure? What's the total number of triangles? 1, 2, 3, 4. 4 is the total number of triangles. So I know my denominator, my number in the bottom, should be 4. How many of those triangles are colored in or are shaded? 1, 2, 3. And then how many are not shaded or unshaded? Just 1. So this is what my number bond looks like, but I'm not done because I know that I need to decompose until I get into unit fractions. So as I said, unit fractions just represent one part of this figure. So how can I break down 3/4 into unit fractions? Well, I just need to break it apart 3 times to get to this 1/4 3 times. So I have 1/4, 1/4, and 1/4. Okay. And I have 4 total figures and I have 4 numbers, so I know I am correct. Okay. So your job is to do now B, C, and D on your own. And I'm going to set you up right now for question number 6. So it asks, the chef put 1/4 of the ground beef on the grill to make 1 hamburger and put the rest in the refrigerator. Draw a 2-part number bond showing the fraction of the ground beef on the grill and the fraction in the refrigerator. Okay, so let's start off with my number bond. I know that 1 will go on top because the number bonds are just representing one figure. And I know that 1/4 will be one of my numbers because 1/4 is the number of ground beef the chef put into the grill. And we need to figure out how much is now in the refrigerator. Okay, so how much would go here? 1/4 plus what would equal to 1? Or how many more fourths do I need to equal to 1? Well, I remember from up here, I need 4 4s to equal 1. So I know that each of my unit fractions is going to be 1/4. So 1/4, 1/4, and 1/4. And remember what we learned about adding fractions? We know that the denominator always stays the same, and our numerator is the one that gets added. So 1, 2, 3. So the chef put 3/4 in the fridge. I could also represent this on a tape diagram figure. 1, 2, 3, 4. And I'm going to shade what's in the fridge, which is 3/4. So shade 3 of these boxes, 1, 2, 3. Okay. And using that information, you guys are tasked with doing A, B, C on your own.